So good evening, everyone. My name is Sylvain, and along with the team, we have Jan, we have Sasha, Trini, and all of our teachers and TA. We're super, super happy to welcome you for this 30-something demo day. We stopped counting, sorry, but it's quite a lot. Thank you so much for being with us online. We're super happy to have you with us. Unfortunately, maybe I should mention that I believe that maybe Douglas is watching us online today. He couldn't be here for the first time in a long, long time. He got a bad injury and he's recovering. So take care, Doug. Maybe we can give him a small round of applause. I don't know. Well, that's for you, Doug. Cool. Tonight, we have two batches pitching. We have a data science batch pitching and a web development batch pitching. But before we dive into the presentation, and for those of you online, because I believe everyone here knows about Le Wagon, what I'd like to do is explain a little bit what we do here at Le Wagon. In 2 words, we are a coding bootcamp. So we help creative people reinvent their career, reinvent their life. And we do this with 2 courses. One is a data science program, and the other program is web development. And we have 2 formats for those courses. The first format is the full-time. So all of our students tonight went through the intensive 9-week program, the full-time one. So they've been with us pretty much every Monday to Friday from 9 in the morning to 6 in the evening, and sometimes even later, especially last night. And the other format that we have is the part-time format. So the part-time format is maybe a little bit more suitable for people who have a full-time job, who have a side activity, but still want to change their life, change their career, pick up new skills for their full-time job. Tonight, we're going to get started with data pitches. So I'm going to be talking a little bit about our data science bootcamp. We had 10 students going through our data science bootcamp. And this is really interesting every time because for our data science batch, it's a fully hybrid bootcamp. We have students joining us here on campus, and we have students also joining us from other parts of the world, including Australia. So the first pitch for tonight is going to be coming from Australia. I'll introduce him a little bit later. Just to tell you a little bit about what they've been going through. They went through the very, very basics of Python, started with useful and powerful Python libraries through decision science, so the power of analyzing data and turning them into business insights. And then they went through the meat of the bootcamp, which is machine learning and deep learning. The projects that you're going to be seeing tonight are mostly about that. They, after that, learn how to take those projects and turn them into applications that can be used, which you will see as well tonight. And the last 2 weeks of the bootcamp are focused on their final projects. So the 3 data projects that you will see tonight have been built over the past 2 weeks as teams of 3 and 4. That's about it for my introduction of the data teams. Without further ado, I'd like to invite Nick, who's going to be pitching remotely. Nick, I believe, is with us on Zoom. Nick, if you can hear me, it's your turn to pitch.
Hello, welcome, and thank you all for being here this evening. It's my pleasure to introduce Tutor, a tool to make finding a job easier, because after today, that's what most of us are going to be doing. Our main goal was to develop an application to help those looking for a job within the data industry, because we all know that it's not easy to find the right job. We extended this and also made a tool to give recruiters a hand when classifying job roles based off their needs, and this is to help them attract the right applicants. As well, we wanted to give insights within the industry, such as the location and the salary information of these jobs. So, to help the job hunters, we developed a tool where they can input their skills and experience, and in return receive jobs which our models deems a suitable match. And for the HR personnel and the recruiters out there, our Looking to Hire page allows them to classify their job roles based off their needs through inputting their required skills or a job description. So for those of us who haven't spent the past 9 weeks playing around with data, it can be a bit confusing as to what the differences actually are between the roles. So to put it briefly, analysts analyze and communicate useful insights to business and governments. Engineers are the architects, and they develop pipelines to deliver data to those who need it. And scientists use data to test hypotheses and answer questions about the future. The difference between these roles can be unclear at times, as there is a lot of overlap between them. But we aim to make this clearer for job seekers and job posters alike. So our process to deliver Tutor can be boiled down to 3 main steps. Firstly, we gather, analyze, and clean the data. Second is to build the models, train their algorithms, and test to make sure they deliver accurate predictions. Last but not least, we link our models to a user interface and deploy it online. So let's have a look at our data. So our data consists of more than 6,000 job listings from the US that were scraped from Glassdoor. The key features of this data are obviously the job description and the title, as well as the company, location, the industry, and the estimated salary. Before we could use the data, we had to do some tidying up first. So here we can see a job description that's 3 pages long. It contains a lot of information that isn't actually necessary for our application. Things like the company's history, the benefits of working there, and the interview structure. So we got cleaning, and we turned it into something like this. There we go. And while it might not make sense to us, this is actually much easier for our models to work with, just the necessary information. So speaking of models, let's have a brief overview of the 2 models that Tutor utilizes. So through machine learning of natural language, we trained 2 models on our data, which now deliver either a suitable job position for the user or a suitable title for the given job description. Firstly is our model to find jobs based on the user's skill and experience. This is a nearest neighbours model, and it groups samples, in our case words, based off their proximity to a given point. And as you can see from the visualization, the data points that are nearest to each other are grouped together. This model takes in a binarized input, so that is to say either the word is there or it's not. And here we are basically training the model to learn what words a job description should contain for each role. Secondly, we used a support vector classifier model to help recruiters label their job opportunities based on their key requirements. It's almost like what would happen if you tried to wrap multiple GIFs in one large bit of wrapping paper and keeping all the GIFs separate. So the support vector classifier takes a vectorized input, meaning a numerical statistic that reflects how important a word is within that document, and finds the optimal hyperplane or wrapping paper to divide these words into the classification in which they belong. So on the next slide, we can see an example of word rankings for our vectorizer. So just a few things of note, we can see the word statistical and interpret under a junior analyst, research and science pop under a mid-level scientist, and systems, software and pipelines are all under senior engineer. So here we have a basic progression of the model development. There we go. After the data is acquired, checked and cleaned, we transformed the keywords into numbers to use for our models. Once the models had been trained on the data set, they were tested with separate validation data to ensure there were no high levels of bias or variance in our predictions. We cleaned our data again and again until we were happy with our model's predictive abilities, and then it's ready for deployment. So with our models trained and tested, we packaged them up with everything they needed and stored that tidy little box on Google Cloud, where that could then be linked to our user interface. So let's have a look at that. So here is our front page. And here we've got some insights into the 6,000 jobs in our data set. So here we show where in the US these jobs are. Below that, we show the industries which are hiring. And here, as you can see, the vast amount of jobs are in information technology. And the majority of the jobs fall under the analyst title, followed by scientists and then engineers. And below that, we can see the salary distribution for the different industries. Though we must keep in mind that these salaries are only estimates given by Glassdoor. So on the next page, we have a job recommendation tool. And here we have checkboxes where job seekers can input their skills and experience and receive the job listings that they are matched with. So for example, let's say we've got skills in data analysis, data visualization, data science, obviously, and maybe a bit of SQL as well. And maybe we've got 1 year of experience. So when we hit that box down below that says happy with your description, what that's going to do is fetch for us the jobs which it deems suitable for us. Now, this can take a little while, but that's while our model decides which jobs to recommend us. So here in just 1 second, we'll see them pop up below. There we go. So here, our first role might be a data warehouse analyst. Below that, I think we've got a business intelligence analyst. Yep, and so on, so on. It'll spit out 5 descriptions based on your skills and experience. So then further on, onto the next page, we have a job classifier tool. So here we have a text box, and here a recruiter or someone can put in their requirements or a given job description and find the label most suitable for that job. In this way, they can attract the right applicants for their job. So here we see Joe copying this fresh job description. I believe this one is off Glassdoor. And as he pastes it in, and he'll hit enter, and it hopefully will spit out a job title for this role. And here we go. This can also take a moment. So what happens here, Tutor vectorizes the input and passes that to our model, and our model makes a prediction. So here we see an intermediate data analyst. So excellent. So moving on, we have our final page, and that's a little page about ourselves. Now, ourselves are Fong, Joe, and Nick. And here you see a lovely photo we took very late last night after finishing up our project. So from here, we'd love to implement an accurate salary range calculator, not based off just given estimates from Glassdoor, and would like to expand to jobs outside of the US. As well, we'd like to expand to jobs in other technical industries, DevOps, medicine, engineering. We also plan to integrate a job search engine in our job recommendations page, and that way job seekers will be able to see and apply for current jobs right then and there. So that wraps up our demonstration of Tutor. Thank you all for being here. A huge thank you to all the teachers, TAs at the Wagon, and our friends in batch 859. So feel free to scan our QR code and try it for yourselves. Thank you again, and good night.
For our next presentation, we'll have people on site, so we're super happy to have people pitching here, and I believe they are ready to jump in. So without further ado, let's welcome Chris on stage for Deep SEO.
Thanks, everyone. I hope you are ready for deep dive into the Deep SEO. Okay, let's start. Imagine you are an Amazon seller and trying to sell a new product. How do you know if the product will appear in the search for this category? I have this great idea of this revolutionary iPhone case. This is a new iPhone case with the shape of a knife, a kitchen knife. Okay, let's see how it goes. In my opinion, this looks great, but how do I know? The ranking is so low, you can see. There is a concept called SEO, that means search engine optimization. That basically means that how high or low you appear in the search for a particular product. In this case, we are focusing on Amazon, as you can see. So we will try to optimize the search engine for this new product. Our solution consists of the client gives us their data, the title of their product, the description and the features, also their images, and that will go through our model, the deep learning model, and we will make a classification from highest ranking to lowest ranking. Okay. So now we will show you a demonstration of our service. here you can see in the top, our clients input the title of the product, then the description of the product, the features. We have up to 3 images this time. So after that, you can click submit, and you will have a rating from us that will tell us if the SEO is good or bad. So in my opinion, this looks great. This is a kitchen case. So I really don't see anything wrong with this idea. So it should be very high ranking, right? The test was not very good for text. We got 1 out of 10. The image, the first one, very good, 10 out of 10. Second one, also 1 out of 10. Third one, 10 out of 10, very good. And our overall ranking is 2.8, so very low in this case. So I think my idea wasn't that good after all. I can improve next time. So here we have the different product. This is one of the toppest of the rankings. So let's see how our model says in this case. So same as before, we input all the data, title, description, features, and the images. And we will wait for our model to make a prediction. So in this case, we have our text, 10 out of 10, very good. So highest ranking. The images, 9, 8, and 9. So our final score is 9.6. So this is very good in this case. Okay, back to the issue. Usually, if you are an Amazon seller, you don't really know how to evaluate your SEO from the beginning. So you have to go to an expert to do that for you. So we try to make a solution that costs not much money for them and uses the deep learning algorithm to give us accurate response, and they can take better decisions next time. So how did we got here? First, we started with our data recollection. We have a very big data set of Amazon, around 600,000 products and 60,000 images that we use for our model training. For that, we pre-process the data. We pick the title, description, and features, also the images, that we after input in our model. We have 2 models, one for text, one for images. First, the CNN model, that's convolutional neural network, that takes an image and transforms it into a bunch of numbers that says this pixel is this color and the place of the pixel. The model goes through the image, scans, and sees shapes and the overall composition of the image. And after, we have a classification of the image, if it's ranking good or bad according to our model. Next, we have a RNN model for text that does something similar. So we transform the text into numbers that we put into an imaginary space. So we can tell if a word is close to one another or far. And we put that into our model and give us classification again. For that, we put everything, both models, into our backend that is hosted in Google and in an API. And our frontend is in Heroku and Streamlit. To conclude, this model is not perfect. We have around 50% accuracy for text and 80% for images, which means that each time we made a prediction, we have a 50% confidence that the prediction is correct or incorrect, and same for images. Right now, we are limited in only one category out of the 36 in Amazon, so that will be a next step. And in this case, we didn't account for the paid advertisement that boosts the product appearance, and also we didn't account for Amazon-owned products that they boost themselves to get better sales. With that, I would like to thank everyone here, all the team in Wagon, all the teachers, the TAs, my amazing team, Nayeon Kim, Elizabeth Koch, and myself, Cristobal. Thanks for everything.
Let's welcome Brian for deep painting.
Hello, everyone. Thank you all for coming tonight. I'm Brian, and I'd like to tell you about Deep Painting app. So, do we have any art lovers in the audience tonight? Excellent. I see a lot of hands. Great. Well, I'm going to need your help because we want to start our presentation with a little game. So here we have 6 portrait images from various artistic movements or artistic styles. Can any of you guess any of the artistic styles that you may see in the images? Rococo, yes, that's one of them. Any other guesses? How about the top left image? This is a famous portrait. Yes, that's correct. And maybe my teammate Gilles can help me unveil the various movements we have here. So you're right, this is actually from post-impressionism, the Van Gogh. Next, we have a Japanese style. This is ukiyo-e, an example of high Renaissance, Impressionism, Rococo, and finally, a Northern Renaissance. So this was really challenging for me, and I'm guessing also for you. And my team wanted to develop an app that can help us identify these images. So we developed a web app that uses deep learning to classify paintings into these various 6 artistic movements. And it can make anyone an art expert very easily. So we started with finding a data set, the portrait painting data set for different movements. And this data set has roughly 1,000 images. And the images are broken down into the 6 major artistic movements that we just took a look at. So how does it work? This is the process. It's very straightforward. We scan in an image. Then we use our powerful AI model to check the image. Then we make a prediction. And as you can see, the prediction is post-impressionism, as we just saw earlier. So how does it work? This slide may be very familiar if you paid attention to our previous presentation. This is an example of a convolutional neural network. And we use this for our model. And what it does is scan an image for various features from the image. For example, it could be a zebra stripes. It then applies this among several layers and then flattens the image to ultimately make a prediction for the classification. In our case, we used it to classify the 6 painting styles. Also, we leveraged a technique called transfer learning. This allowed us to use a pre-trained machine learning model to improve the performance of our prediction. And in our case, we use the exception model, which is developed by Google, and it has over 71 layers. And also, it can classify images into over 1,000 different categories. So this helped us improve the performance. So talking about performance of our model that we built, essentially our model can classify correctly 7 out of 10 images that you can give to it. We have a graph showing this performance, and we used accuracy as the metric. And we are looking at the accuracy of the model on both the blue training set and then the testing set in yellow for over 20 epochs. An epoch is essentially showing the model, the full data set, one time, and it continues to learn as it sees the data more and more. And now I would like to hand over to my teammate Dipanjali, who will give us a walkthrough of the Deep Painting app.
Thank you, Brian. So this is welcome all of you to the Deep Painting app demo first of all. And as you can see, we have 6 sample images for each of the different artistic movements. And you can see the drop-down bar below. And if you click on it, you'll get the summary for each one of it. And then, as you know that our model is able to predict on different artistic movements. So why not to quickly take an image and predict the result, right? So hopefully everyone knows about the painting Mona Lisa, right? Right? Okay. So anybody knows the style for it? Any guesses? Okay. Right guess actually. So let's give the model Mona Lisa. So where are you, Mona Lisa? Okay, so it's still loading, running, still running. Technical issues sometimes. So okay, so yeah, so probably we'll be giving the model. So Mona Lisa is we have used Mona Lisa as a training data set. So we have already trained the image. We have already trained the image on our model, and then we'll be getting the results here. So okay, it's still running. Hopefully Mona Lisa do not want to show up here. Okay, so we have the Mona Lisa, and so the app predict the image as high Renaissance. That's good. So let's try another image. Right? So the second image we'll be using is let's try a second image. So it is Yukio, one of the famous paintings, Japanese painting we have. Let's see what the model predict, and the model predict it as Yukio. Great. So this app is not only for the classification of ancient historical portrait, but you can test it on any image. So that gave me an idea. Let's see what the deep painting app, predict regarding the deep painting app team. Very wonderful people, I must say. So okay, so the deep painting app classifies this image as high Renaissance. Good. So guys, if you need to practice more and level up your knowledge, we have built a game for you. If you can see in the left side of the bar of the app, there is a game. So I need a volunteer first of all. Anybody? Come on. So Sylvain, why not you try? Do you want to try? Okay. So here we have so so just select one of the options. Okay. So let's try Rococo. See. Okay. Submit button. Oops. Well played. Well played, I must say. Anyone else? Come on, guys. Okay. Submitted. Well done, Jill. That's good. So Jill, let's go back to the slides. So ladies and gentlemen, this is not the end. It is just a beginning. So our next step would be to enhance the model by training it on a larger data set, augment the model to identify the artist names, and use neural transfer to turn your pictures into the artistic moment of your choice. And last but not least, here we have a QR code. If you want to play, and you must play actually, I would insist, right? So just go and scan the QR code here and get the app on your phone and play it. Last but not least, I would like to thank Levigon for giving us this wonderful opportunity, and all the TAs, the teachers who supported us, and my lovely and wonderful teammates, Brian, Jill, and Kesar from Australia online. Thank you guys for your kind support and infinite patience. Thank you again for joining us here today.